And now we are going to apply the classification algorithms on our dataset. As we have told earlier that in this project we are going to apply both classification algorithms and regression algorithms. Regression algorithms to uh, predict the AQI score for our dataset, and the classification algorithms to classify the AQI range, classify the air quality based on the AQI range. So we are going to apply logistic regression, decision tree classifier, random forest classifier, and KNearest neighbor classifier algorithms. We have imported all the models from sklearn. So now again we are going to split the dataset into independent and dependent variables for the classification, for our classification done. And then we are going to split the dataset into training and test data. This time we are taking 33% data as test data. The rest 67% data will be used for training purpose, training data. And again we are using the random state as 70. So this is the shape of our X-train, X-test, Y-train and Y-test data. So now we are going to feed the model. The first model is logistic regression. So we feed the model using the X-train and Y-train data, and then we predict on the train data and we check the accuracy on train data. As we can see that accuracy on train data is 0.72. that means 72% of accuracy it's showing on the training data. And then we predict on the test data and we check the accuracy score, and finally we check the kappa score. Kappa score is nothing but a validation matrix. It shows how accurate the model is. Over here the kappa score is showing that the score is 0.58. that means the accuracy is 58% for this model, the logistic regression, and 58% is a very poor score for this dataset. So we are going to ignore the logistic regression classifier. This model did not perform well on our dataset. Now we are going to apply the decision tree classifier on our dataset. So we have done the same thing over here. First we have fit the model on train and test data, and then we have predicted on the train data, and we have checked the accuracy on train, and as you can see that it's showing the accuracy on train is 1. Then we predict on the test data, and we get the accuracy on test data, that is 0.99, and the kappa score is 0.99 over here. And as we know that if the accuracy on train is 1, that means the model is overfitting. So our decision tree classifier is overfitting. And what is overfitting? If you don't know, no worries, I will explain this later. I'll have a complete video series on machine learning, so you'll get what is overfitting. I'll explain it in the playlist, no worries. So we're going to ignore this model as well, decision tree classifier, because the model is overfitting. Okay, now we are going to apply the random forest classifier on our dataset. So we have done the same thing for this model as well. We have fit the model on train data first. We have fit the model, and then we have predict on the X-train, and we have checked the accuracy score, that is a evaluating matrix. Okay, so we are getting the accuracy 1. That means this model is overfitting as well. We got a very good kappa score though, but the model is overfitting because the accuracy on train is 1 here, so we have to ignore this model as well. If any model is overfitting, that means this model is not accurate, so it's better we ignore the model, because overfitted model will never give pretty good accuracy on predicting, so we'll always ignore if the model is overfitting. And finally, we're going to apply the k-nearest neighbor classifier algorithm on our dataset. So we're doing the same thing for this model as well. We're going to fit the model on train data, and then we predict the X train, and we check the accuracy on X train using the train preds, that is the prediction on train data. So we're getting 0.99. That means the accuracy on train is 99%. And then we predict on the test data, and we check the accuracy on test data, that is showing the accuracy is 9.9, and that means the model on test is 99% as well. And finally, we check the kappa score, Cohen's kappa score, and the kappa score is 0.99. That means the model is 99% accurate. So this model is really a good model. This classification model, k-nearest neighbor, is giving a very good accuracy. So over here, what we are doing, actually, we are testing the model we have built, the final model, that is our k-nearest neighbors model. And we are testing this model using some random values over here. These are nothing but the random values, and these random values are nothing but the individual pollutant index. So main goal is to give the individual pollutant index as the input, and get the air quality category as output. So we give individual pollutant index. These are nothing but some random values. We are just testing the model right now. So we are giving this data as input, and over here, as we can see, that it's saying moderate. That means the air quality is moderate for these values. So if the individual pollutant index like sulfur dioxide, nitrogen dioxide, SPMI, and SPI is these values, then the air quality is moderate. Very good. Then we do another test, and it says that the air quality is good, and it's poor here. So our model is working very fine. It's giving a very good output, because when the pollutant index, individual pollutant index values are high, like here, then the air quality is very bad as expected. And if the individual pollutant index values are low, like 1, 2, 3, 12, 0, then the air quality is good. So the model is working very fine. So right over here, we are going to evaluate the model. So for that, from sklearn metrics, we import the accuracy score, we import confusion metrics, and F1 score. So the accuracy, we have already seen that the accuracy is 99%. That is very good. And over here, we're going to print the classification report. So this is our classification report for this for KNN model. We have our precision, recall, F1 score, and support, and finally the accuracy is 99%. So we have successfully predicted the air quality based on machine learning, and we have done some analysis as well. So from the beginning, I'm going to give a quick recap. So the main goal is to predict the air quality and analyzed it based on the machine learning, and we have imported all the necessary libraries first, and we have get the basic information of the data using some function. We have got all the information about the dataset using like some describe function, column names, etc. Then over here, we have visualize our data. As we can see, we have pretty beautiful visualization of our data to understand the dataset properly. So for the first part, we have analyzed the data, we have played with the data set, we have get so much information from the data, and finally we have splitted the data set into dependent and independent variable. We have calculate the air quality index based on some formula, like this formula we have used to calculate the AQI air quality index. Then we have get the AQI range using some function. Then we have finally apply machine learning algorithms. We have used both classification and regression model on our dataset. We have used the regression models first uh, to predict the AQI value for the individual pollutant index. Then finally we have used the classification algorithms to classify the air quality, like how the air quality is, if it's good, bad, moderate, how it is it. Finally the model gives output if how the data how the air quality is, like moderate, poor. So this was it. Thank you everyone, have a good day.